Morning. Okay, so I found some problems I've done in previous years. So if you want to grab a scratch sheet, we'll start off with number 1 here. Oh yeah, you want to take it right now? Right. Let me read your phone is 36. I'm gonna put you in the other. And grab a scratch. Okay, so log base 5, we know that we want to expand first. So this is the same as if you were doing natural log of A over BC. This will be log of A minus log of B minus log of C, right? Anything in the numerator is part of a positive log. Anything in the denominator is part of a negative log. Okay, what can we do next? exponents down. Yeah. So there's not power rule for derivatives yet. This is just expansion. So we don't bring the 2 down and subtract 1 from the exponent, right? We just bring the exponent down. That is to make our u prime over u derivative easier to work with. Okay. So now we can apply our derivative rules. Remember the rule for log base a of u is 1 over natural log of a times u prime over u. So my a value is 5, and my u value is whatever's inside the log. The 4, the x, and the 1 minus x. What's going to happen here, though? Log base 5 of 4. What's the derivative of this? Do you see any variables here? This is just a what? A number, right? What's the derivative of a constant of a number? 0. 0, right? I mean, you can go through this rule here. 1 over natural log of 5 times u prime over u. The derivative of 4 is 0. So 0 over 4, that's going to 0 out. Okay. All right. Apply the derivative for these two terms and try that. I'll go over it with you, but want to have you guys try it first. Is the a.
Right, so the 2 goes in front of the.
That's right. Yeah, the 2 is not part of the derivative rule. It's just a coefficient. It's going to hang out in front. Okay, next step, derivative. The 2 stays, log base 5 becomes 1 over natural log of 5 times u prime over u, so times 1 over x, minus, coefficient stays, 1 over natural log of 5, u prime over u, 1 minus x becomes -1, divided by u. My u is the original parentheses there.
Why does the middle become a addition instead of subtraction?
Oh, the reason why is because there within this last fraction, there exists 2 negatives. So the -1 is going to cancel out without negative. So I made the 2 negatives possible. Okay, any questions? All right, here's number 2. Anybody still need one? Justin, I'm creating new. I found some additional problems, so you can grab a scratch sheet or just follow. Okay, first, what can we do? Yeah, good. And then what's next? Well, we can't just bring it down. I mean, maybe you're thinking chain rule, right? But this isn't chain rule. What method do we have to involve for this problem?
Put in a natural law.
Yeah, we have to involve natural law because we don't have a rule for this. Okay, this is not it's not power rule. It is not, it's a variable raised to variable, right? So do we recognize that the need, this is a variable raised to variable. We don't have a rule that can handle variable to a variable. So if we involve natural log on both sides, then all of a sudden that exponent can be free to move. Because right now, if you just move it down, I mean, you're changing the problem. And then you're also thinking of this as power rule, which this is not, right? I mean, we can do chain rule for a problem like this. If it was y equals x squared minus natural log of x raised to the 7th power. This is chain rule, right? This we can handle using old rules outside of this side derivative. But as soon as we introduce a variable to the exponent, and there's a variable in the base, this is problem that we have to. The only way that we can work this through is involving natural log and forcing this to do a different form. We see that the need for log differentiation here. I'm going to rewrite it as 1/7 x just so that it feels easier to work with this once that comes down, because x over 7 feels like, oh, I got to go through quotient rule, but there's no need for quotient rule within this expression. 1/7 x is just power rule, right? Okay, natural log of both sides. Okay, so now that we're inside a log expression, where can that 1/7 x go?
In the front.
In the front. Okay, so now when you move that 1/7 x, you're not changing the equation at all. You're just putting it to a different form. If we did that x over 7, if we move that down to the front in the beginning, we're changing the problem and we're applying a rule that there's no derivative rule that can handle that. So, but right now we're still not at the derivative stage yet. We're just using log properties here. Remember this property here. If I have natural log of a to the n, I can expand that into n times natural log of a, right? So I can move the exponent, move it down as a coefficient, move it up as exponent freely without changing the overall value. But this will help us with our next stage if we were to move that 1/7 x down. So now we're ready for our derivative. The right side, we can't escape this. We have to go through what? Go to the product rule, right? So if you see a variable raised to a variable and you apply log differentiation, there's no way around product rule. You're expecting to apply product rule. What does natural log of y turn into? Derivative of y.
Y dy dx.
Yes, 1 over y dy dx, right? U prime over u followed by implicit. Okay, f prime g plus f g prime. Okay, what's 1/7 x's derivative? Just 1/7, okay. And the g and the f doesn't change. We just have to worry about how to get to g prime, right? Okay, so what rule do we apply to find the derivative of natural log of x squared minus natural log of x? So the large rule at play is, what's natural log of u's derivative? If u prime for u. My u value is this x squared minus natural log of x. So the derivative of this is going to go in this space here. Right? So what's the derivative of x squared minus natural log of x?
2x minus 1 over x.
Yep, 2x minus 1 over x. So that derivative that you just said is going to go in this spot within this larger natural log rule. And then the u value in the denominator is just this x squared minus natural log of x. I'm creating new problems from that I found previous year, so grab a scratch sheet. Okay, so we've gotten past the hardest part. We found the derivative. The rest of it is just multiplying that y over, solving for dy dx, and then replacing the y in terms of x. But is everyone okay getting to that derivative from natural log of u to u prime over u? Okay, you move that y over to the right. You don't have to clean up the way that I cleaned up that g prime. You can leave it in this form. I just did common denominator. But the important thing is make sure that you bring that y back over and that you represent your y in terms of the original variable x. So no y's in your final derivative.
You made it 1/7 natural log of the 7 root.
No, the seventh root is just from the original equation.
Oh. Where did that 7 come from? In the denominator?
Oh, right. So it came from this f here. It's f g prime. I just merged this together. You don't have to. I put that 7. All this being multiplied, so I just move that 7 to the share the same denominator space as this x squared minus x plus. Yes. If you start out with a variable raised to a variable and you do log differentiation, you have to, there's always product rule. Because what happens is if you have a variable raised to a variable and that variable comes down, then it becomes variable times a variable. And there's always product rule there.
What are the different like procedures that you might start off with? Like I know one's expansion, one's like,
Mhm.
what's over.
There's also this one here where we have to do derivative of inverse set of points. We can try that one. Okay, everybody good with 2? Number 3, find the derivative of f inverse at 2, given that f of x is x cubed plus 2x minus 1.
We have a problem on the quiz with the fourth. The
A to the
A
u.
to the U.
Yeah. And I'll have that.
I like this the graph one. We not the graph. Like,
Right, this is the graph one, right?
And those are the 4 different like log differentiation properties with that, right?
Say it again.
Those are the 4 different log differentiation properties with that now, right? That ordered on that.
Oh, you mean that little quadrant thing?
Yeah.
Yeah, that's just to help us make sure we see that relationship between function and its inverse. So the way we can start out the problem is we know that 2 is the x value of my inverse, which must mean that 2 is the y value of my original function. Right? So before we begin anything, we know we got to make it fit into this form, right? You know that this 2 is not really the x value of the original. It's the y value of the original. So understand whatever the number they give you is actually the y value of the function. So we got to make sure we insert the 2 into the right place because we know that f of some x value equals 2. Yeah, that d over dx just means the derivative of f inverse. Yeah, it means the same thing. That's right, same thing. Yeah, these mean the same thing. They just, that d over dx, the same thing as that prime there. No. I'll always ask you for the derivative of f inverse. Yeah, I'm never going to ask you for that. That's right. Always whatever you're looking for is going to go up here. At least the way I do it. Okay, so we can go ahead and try to solve this equation, right? 2 equals x cubed plus 2x minus 1. We know we got to do a little bit of guess and check here. Bring everything over to one side. What number can we get with this? We'll make this work.
Everyone equals 0, right?
Yeah, I got plug in an x value that will
That'd be
force that to
one.
be the same. Okay, so if I plug in 1 cubed plus 2 times 1 is 3. 3 minus 3 is 0. So 1 works.
You said it would be it would be more than 3 or -3, right?
Right, right. It'll just be between -3 and 3. Okay, so we know 1 works. So if I can find f prime of 1, then this slope will lead me directly to the slope of the f inverse at 2.
Is the graph in red the same graph as the graph in the original graph you drew?
Yeah, I just wanted to show that this is where we can start before we begin anything, and we can begin to update our table from here. Once we find that 1, then things can begin put into place. Okay, so first let's find f prime of x, which is 3x squared plus 2. Plug in 1, and we get a slope of 5. So if the slope is 5 on the f side, then on the f inverse side, it must be what?
1/5.
1/5.
You keep the sign the same.
Keep the sign the same, just flip.
It'll always be the same format, like you always be looking for inverse of something.
Yeah, I'm always looking for the derivative of f inverse at a point.
So it'll always be that bottom right quadrant. That's
Right, right. But you're always going to put whatever you're looking for in the bottom right corner. So I'm not going to have that table drawn for you. You're going to create one yourself. Okay. I'm going to jump around here. This is number 6. Okay. How would you start this?
Spinach. You're bringing
Put natural log as those sides.
Yeah. So, I mean, we can expand if it's part of a natural log. There's no natural log here, but if we introduce natural log into the equation, then we can do log differentiation, right? Why do we need log differentiation for this equation?
That variable is there.
Yes, variable raised to variable, right? That 2 to the x is still an exponent variable there. So you got a variable raised to a variable expression.
what was the giveaway that was log differentiation?
The giveaway with log differentiation is if you have this form here. I have a variable raised to variable, right? If I have a variable raised to a constant, this will be like power, this will be like x to the fourth. And if I have a constant raised to a variable, then that's exponential, right? That's like 2 to the 3x. Right? We have a rule for this, right? This is the natural log of a times a to the u times u prime. So we want to be able to recognize the distinction between these three types. So power rule here, chain rule. This also works. If it was like x squared minus 6 to the fourth, that's also power rule, chain rule. As soon as I have a variable raised to variable, we're stuck. We got to go through law of differentiation. Okay, what's our next step?
No, bringing the thing.
Yeah, bring that 2 to the x down. So left side is just 1 over y dy dx, right? Natural log of u is u prime over u times, we got to go through implicit here. Okay, what rule do we use for 2 to the x? A to the u, right? That's the a to the u rule, right? This is a exponential function. So a to the u is natural log of a times a to the u times u prime. Okay, so what's the derivative of 2 to the x?
Natural log of 2
Mhm.
times 2 to the x minus x.
Times,
Times x.
well, what's x's derivative?
1.
1.
Yep.
Okay. Now, yeah, so if this was a more complicated exponent, then you got to make sure you do the derivative of that exponent over here in this space. Okay. G stays the same, F stays the same, and then what's G prime? What's natural log of 3 minus 5x? Over,
Oh, minus 5 over 3 minus 5x.
yeah, U prime over U. Okay, bring that y back over, and then replace the y back in terms of x. Your answer with law differentiation will just be messy, but don't try to combine anything. Just leave it in that form. If you try to combine, you're probably going to combine incorrectly. So, I mean, you could, but you got to do common denominator. It's not worth the hassle to go through that. So just leave your answer.
Are you looking for the most simplified version?
No, I don't want most simplified version. I feel like if you try to do simplified, you're going to make a mistake. So leave your answer on unsimplified, and that way you're never. Same thing on the AP exam, right? The more unsimplified you leave it, the more time you save, and the less chances of making additional error if they're already going to give you full credit.
Maybe you leave it like after the power rule. Like, I mean, maybe you leave it like that.
Which part?
Like after the power rule portion, like I can see that's the time you run.
Yeah, that's right. You can leave this separated if you want. Any questions?
The last few steps you wrote down, is that like all you did was like simplify it more? So you can,
I do want to make sure that I bring that y back over to the right, and I gotta replace that y in first place. So I am looking for this step. For this, you don't have, you can keep it in this form or keep it in the form above it. You don't have to go as, you know.
Can you explain that step again?
Okay, which part?
The 3 minus 5, like how you got that? At the bottom, where like the answer is like 3 minus 5x, but to the power of 2x.
Like the line being replaced.
Oh, yeah.
Oh, right here, this way. So y, what's equal to y? Y is equal to what? The original, right? So you just have to bring down the original. Yeah, so we want to, when we go to law of differentiation, you want to represent your derivative in terms of just x. So just remember y is only a temporary variable on the right side. So yeah, that y will be replaced with the original equations. Right, how would you start this problem? Let's expand it, yeah. This is a part of a log expression, so pretend like this was natural log of a divided by bc. You can make it log of a minus log of b minus log of c.
Is one bring natural log of a into the denominator?
Yeah, that's right. Yeah, log of that's right, because log a of u is just 1 over natural log of a times u prime over u. Excuse me. Thank you. Okay, everybody okay with all the expansions? So no calculus yet. We're just cleaning this up so that our derivative can feel easier with 3 smaller problems rather than one large one. Because they're in the denominator. It's like quotient property. Right, so if I had log of a over bc, that's equal to log of a minus log of b minus log of c.
And you made it a 1/2 and you brought it over.
That's right, yeah, that radical is greater than 1/2. I brought that 1/2 down. Okay, so now we're ready to apply our derivative rules. Each of them will take on the 1 over natural log of a times u prime over u. All right, so let's do this one term at a time. The 3 is going to stay, right? What's log base 7 of x going to turn into? times
X. Front is 1 over.
1 over x, right? X derivative of 1, so 1 over x.
So 3 goes in front. of all?
Yeah, that's right. There's just a coefficient in front of a variable, right? Yeah. What about 3 log base 7 of e to the 2x? 3 stays.
EU times u prime.
So, log base or 1 over natural log of 7. Okay, now u prime over u, right? So u prime is asking for the derivative of e to the 2x. What's the derivative of e to the 2x?
E to u times u prime.
Yeah, which would be what? So
E to 2x times 2.
times 2. So e to the 2x times 2 will go in this space divided by what?
E to the 2x.
E to the 2x. And the last term is very similar, 1 over natural log of 7, u prime over u, we do a power rule.
Cancel out the e's.
Cancel out e to the 2x because they're the same. Basically your answer, do a little bit of, I mean, you don't have to clean up, but this is what I did to clean up.
Will you take off if we don't simplify the 18 over 2 into the 9x? Because you do 3 times negative 6x, so it'd be 18.
Oh, yeah, you don't have to.
Okay, cool.
I simplified that.
Every squiz next.
Yeah.
I'm not.
Really? I thought yesterday.
Well, these properties are gonna stick with my head.
Yeah.
How many different like of these properties are there? Is there 4 main ones like the?
Let's see, I have a worksheet one. So on worksheet 1, I had the properties that you're responsible for. Natural log of e is 1, natural log of 1 is 0. It's just showing that if I insert natural log into e to the x, I'm getting x. But the main ones are, you got product property, quotient property, power property. And if I have a mixture of product and quotient, just know that anything in the numerator is a positive log. Anything in the denominator is part of a negative log.
So the 4 main ones are here.
Mhm.
Okay. What about like the derivative?
Derivative, yeah, we have the 4 derivative rules up on the board there. You got natural log of u, e to the u, log base a of u. We do that every day, right? Just having you guys go through those 4 rules. Okay, I have one more for us. Find dy dx. What is involved here if we want to find the derivative? Implicit? Yeah, you see y is all over the place. Okay, what else?
Product.
Product rule, yeah, product rule with 3x squared y, we gotta go through f prime g plus f g prime for that. And then what should we do first before our derivative begins? Expand that left side, yeah. Natural log of a over b. Can be expanded as natural log of a minus natural log of b.
Let's expand the left side, but not the right side.
Yeah, the right side, there's no natural log, so we can't expand the right side, just the left side. You don't have to go through as many steps as I did. You can just jump from here down to here if you want. I just showed the step radical, the rational exponent to that one there. Everything else I haven't done anything to. But once we're here, we're ready for our derivative, right?
You need to do power rule
Uh,
or product rule, it's like.
product rule here, yeah. But we'll do U prime over U, U prime over U, we'll do product rule, power rule, power rule, power rule. Okay. All right, 1/3 natural log of Y becomes.
One of them.
Okay, what else?
You probably rewrite.
Mm-hmm. But we also know it's implicit. So what does that mean? Well, let me ask you this. At the very beginning of the equation, we know there's implicit. How many dy dx's are we expecting? 3, right? This is one of them. One of them will show up because we're asking for y's derivative.
So like UIDX times 1.
Yeah, it'll be 1/3 times 1 over y times dy dx.
So you keep the 1/3 there.
Yeah, it's a coefficient, right? Anytime there's a coefficient in front of your variable, it never goes away. Right. Okay, next. 5 natural log of x becomes.
That's fine.
5 times 1 over x. 3x squared y, we got to go through product rule, right? Right, so 3x squared becomes 6x. G is y. F is the 3x squared. G prime is 1. Anything else?
UIDX.
dy dx. Yeah. Minus is y's derivative.
UIDX.
Yeah, I like to put a 1 here as a reminder that if I were to factor that dy dx out, I don't forget that there's still a number there. So I'd like to put that there as a reminder. Okay, 5x is minus 3, 0. Okay. We're expecting 3 dy dx's to come up, and we do. So now the calculus is done. Now you're just rearranging, moving things around, getting the dy dx terms on the same side, on the left side, so you can factor that dy dx out.
How many problems are we on the quiz?
7.
So
Okay, any questions about the steps for this problem?
it's can you have that the X and Y variables back together, like at the end. X, Y.
6x, y. What about it? Oh, yeah, that's right. It's okay to have x's and y's in the equation. This is not log differentiation where we gotta bring the x back. Leave your x to the y's alone. Because we're not starting with a function, so we don't expect the derivative to produce something that can be a function as well. But because a problem like this is a function, that means we should be able to represent our derivative just in terms of x. We don't need a y in our derivative. So that's why we always break back our x, understanding the y is only a temporary variable.
Different problem we haven't gone.
Yeah, tangent equation. Okay, so tangent equation means I need to find the derivative to get to the slope. Once I get to the slope, then point slope form. But to get to the derivative, what's needed here? Product rule, right? F prime g plus f g prime. We got to apply the rule for e to the u, which is e to the u times u prime, and also an log of u, which is u prime over u. You don't have to clean up the derivative and leave it. But once you get to the derivative, what do we want from the derivative? Or what would your next step be after you get to the derivative?
Go up to ease. Right?
Plug in the x.
Because why? Because you want to find the what?
You want to find the
Or
y.
just slope at a point.
Yeah, slope.
We have the slope. Yeah, we have the order pair. All we need is a slope, so the slope's going to come from the derivative. So we're going to turn the derivative into a slope value. Right. So we'll do f prime of 1. So replace every x with 1. So I have e to the -1 times -1 times natural log of 1. What's natural log of 1? 0. 0. That's good, right? That's going to wipe this whole thing out. E to the -1 times 1 over 1. That's just 1 over e. So my slope is just 1 over e. And then I have everything that I need. I have my order pair, I have my slope. All right, see if you guys have any individual questions for me.
Like, so number 7, the anytime it says divide the x, do we put the
Oh.
Really?
separation back in, the answer, like, if that's.
Right, that's right. If you do log differentiation, you're always replacing the y back into.
So any time it says use logic.
Or it's a problem where you have to use log differentiation, like a variable rate to the variable. That's the only 2 times you can do log differentiation. If I tell you to, or you're forced into it because there's no other way to do the problem. Yeah, natural log of 1 is 0, that's right.
Also, like, how would you know when to do it? Versus. Like, just,
Right, so.
we haven't done any problem with that one.
Like in the. We did this one here. This one is a to the u. A to the u is natural log of a times a to the u times u prime.
Okay, then how come like up here you would do this?
Because this log base a of u. Log base a of u is different from exponential. Right. So the derivative of a to the u is actually log of a times a to the u prime, but I'm going to have log base a of u. The derivative is going to be 1 over natural log of a. Thank you. Thank you.
So.
I know we have a bit messy conversation, so distracting, that's not right.
Is also
No,
one here.
So that much. That's right. Okay, see.
This is the first question. What did you come with? What and so it's much fun for one. Yeah. Or like I watch it through and we're not going to these like I don't know when. I know, but I think you can do this. I want to do that too, honestly.
Yeah, I just do this for.
I love it. I didn't memorize these full shots. I memorize them. Yeah.
That's fine.
And the other one's like how to start.
Are you?
How to start that too. No, I know. He's bringing that line back. Later, I'll just cancel it. Oh, wait, that might tag it too. That's your. That's you. Yeah, that's fine. Like that. That's like curious. Because I was gonna be asking if what it is.
When you're doing the log yeah, the constant goes bigger. Yes, because if you follow the rule, 1 over natural log of a times u prime over u, so that's 0 over 4. So also that's just a number, right? There's no variable, so it's always okay. Cool.
This one right here also, but it's because it's also divided.
It is dy dx, but this is just the nature of
Right.
implicit. Implicit, you're gonna have dy dx's, you're gonna have a bunch of y's in your answer, which is fine.
So it'd be
But with log differentiation, that's the only time you gotta just know that your y is only a temporary variable.
that gets plugged back. That
This
gets
gets
plugged
plugged
back.
back in. No, they just.
Just these two.
Yep, just those two. That's the only time you replace the y back in terms of x. Yeah. Yeah.
You know.
I got it.